Hello. Smiley face. All right. Here's the thing. Protractors. Let's say, watch this. I got a line, and it's got a true line because it's got arrows on each end, right? And there's a point right here. Let's call it point P because that's my favorite letter in the alphabet. It's true. Okay, so then when you use a protractor, okay, you got to line that center dot up with the point, and then you got to get the line to go through 0 either on that side or that side. Okay, now that's important. Now watch. I'm going to put the center dot, and I get my line going through 0. You can see it go through 0 right there, right? And let's say now I want to measure out a 30-degree angle. I'm going to go, and remember, 30 degrees less than 90, so it's a little one. It's right there. Boom. Put a dot at the 30. Draw a ray like that. Now, let's say a Q and an R, just to be super fancy. And I would call this angle QPR or RPQ. When you call an angle PR or angle RPQ, when you name an angle, it's important that the vertex is where the two rays connect, are in the middle in the label. 10-4. That looks good. That looks good. Oh, coincidentally, if that's 30 and you just saw me do it, then this one must be the supplementary angle, because this is on a straight line. We've got a half a circle. You can kind of see I drew the half circle. Sorry, I'm still suffering from that little cold. This then, these two angles must add up to 180 degrees, right? Because that's half a circle. So 30 of it's there. What's the rest of it? Can you think? Can you think? It's that. It's 150. It's so exciting. You seem so excited about this too. Okay, let's do it again. I need a different protractor now, but here we'll do this one. Now you might get caught up in the idea like just having a ray and not a line with a point on it, and that's okay. Angles can be drawn in any way. Which way? This might look kind of funny that it's upside down, but the reality is, as long as I get my dot on the center and I go through 0, then I can draw an angle this way too. So let's pretend I want this to be 120. So I start at 0, where the line goes 120 right there. Now, you're going to be tempted once in a while to mark that as a 60, but notice that once I connect my point, like so, you can clearly see that's an obtuse angle, right, at 120. And if I extended this line out, we could then say that this must be, since it's a half a circle, 180 degrees, and that's 120, then this acute angle here is going to be what? What? And notice that this A, B, C, I would call that angle ABC or CBA. It doesn't really matter which direction you go, as long as the vertex is the center label. Okay, interesting. Tough thing for students to be able to do. I want to show you a different protractor. Hold on. Don't worry. I'll go right back. I'm still here. You're still here. There's this protractor too. Now, I'll just back on this protractor. I want to show you something. You'll notice that. Let's just draw a line. Straight edge. Put a point on it somewhere. Point P. This one, you don't have the hole. You just have this bottom line, and that little line is the exact same center. And just again, make sure the line you drew goes right through the 180 or 0. Sorry, 0. And the reason there's 180 and 0 on both sides is because you read it in different direction, either direction, this way or that way. And if I wanted a 110 angle, 110 degrees from over here, I'd read 0 to 110 right there, and then I connect to my vertex. And, usually you're not going to just have angles hanging out in space. You're going to have letters on them so that we can say, well, this is going to be A, B, C, and D on those points. Then I might say to you, hey, well, what does angle ABC measure? And then you go ABC. Angle ABC must measure 110. Isn't that what we said? 110? I just labeled it. I just measured. Didn't I make it? All right, let me put the protractor on. Yep. And so if that's 110, what's this one have to be? Because on that straight line, a half circle has to be 180 degrees. So 110, supplementary angle of 110 plus what makes 180? You're right, 70 degrees. Cool, neat, nifty. There's so many cool things when you start doing these angles and drawings. Now here's another type of protractor. Just Why is it? You don't have to. What the? Hold on. Okay, this protractor is kind of like this one too, in that it's just got this edge. So once you get the hang of, is that a dot? Of the 0, you're cool. Hey, it says it's made in Israel. It's kind of cool. Ooh. All right. Next, if you wanted to try to draw a perfect rectangle, this always throws kids off. Here's my dot. Should we call it point P? Why not? It's my favorite letter. I need a right angle to begin my what do you call it? Rectangle. And let's say you also need to know your measurements. So let's say I'm going to make this line. I'm going to make it 3 inches this way, because that way up there I'll have to be 3 inches. So let's say we go. How long will this go? 4 inches this way. Now I need a right angle. So what I'm going to do is I'm going to measure a right angle. My dot's off. I'm going to put it right here. I'm going to measure a right angle right there, and I go straight to the 90. Bam, and then I just got to connect it. But this time I'm going to connect it such that it's 4 inches long, and I can barely hold on to my thing here. It even looks like a right angle, doesn't it? Now you can't just go willy-nilly connecting these, because it would be easy to do that, right, in some weird shape. So you got to build another right angle here. And go right. Remember, 0.0 dot at 90, 4 inches. See, this is how you do this. It's hard though, like this. I got to be honest with you. It's going to be easier on paper on the ground. I mean, on the desk. This is kind of like that. And of course, that pen's a little thick up there. Now, once you have this at 4 inches, and you got a 90 there, and you measured 90 there, then you know this is going to end up just going 3 inches, right? Look at that, it did. And so you just connect these two, kind of thing. But okay, that's how you make a really good rectangle. Now, since I drew the rectangle, check this out about all four-sided figures everywhere on the planet. 90, 90, 90, 90, like this whiteboard, like a door, window, whatever, not all things, but just that book, right? This book. All four corners are 90 degrees. So therefore, add them up. Inside a four-sided figure, all four-sided figures on the planet have 360 degrees. Now, you might first go, wait a minute, what about a square? Of course, it has 4 right angles, but it doesn't have to be right angles. If we push this over a little bit so that it kind of did this kind of thing, called a parallelogram. So same thing. This obtuse and this is acute, but they're going to add to 180 together, and these guys are going to 180, and so altogether 360. Any four-sided figures, including the trapezoid, which is kind of weird at first you think about it. I'm going to freehand one real quick. You think about this, and you're like, wait a minute, how can that be 4? Well, here's what happens with trapezoid. You have 2 acutes and 2 obtuse. And if you really wanted to do it, if you had a perfectly drawn trapezoid, measure those angles. If you were like, and this is not a perfectly drawn, but I'll bet we can get close. That's 50. This thing's hard to pick up. Now, what's this one? This one's going to be 130. Ooh, notice that. What do those both add up to? And so, therefore, this is going to be, it's not necessarily because I drew this. Let's go this way. Measure this one here. 120. And so this one must be 1. Come on, figure it out. It's got to add up to. See, it did. Is that bizarre? And I just freehanded. You literally watched me freehand it. So these two add to 180, and these two add to 180, and therefore you have 360. It's a cool phenomenon. You should check it out. You have a geometry song? I like pie to eat. You know, pie is wrong. That's for a different lesson. Okay, now here's what you're gonna do. You are gonna get a blank piece of paper. You're gonna get a blank piece of paper. You're gonna fold it so that you have 4 sides on, but 4 sections on each side. Okay, and then you're going to do these things. First, number 1 is your name. Number 2 is you're gonna draw a 90-degree angle. 3, put letters on it too. You're gonna draw a 120-degree angle. 4, you are gonna draw a 50-degree angle. 5, you are going to draw a straight line, put a point somewhere in the middle of it, and you're going to draw then a 20-degree angle and label the other angle next to it, the supplementary angle. So it's going to look something like this. Don't freehand it, though. You got to use a straight edge, use a protractor. Okay. 6, you're going to draw a rectangle that measures the same measurements that, no, you know what, I'm going to change it. You're going to draw, and you got to use a protractor to make right angles, right? Make 90-degree angles. And you're going to have this measurement. You're going to have Now this is centimeters, not inches. I made mine in inches. You're gonna go 7 centimeters by 4 centimeters. You can draw a perfect rectangle, right angles, 4 by 7. And then you're gonna figure out, number 7, the area and the perimeter of that. Okay, and then number eight, you get to draw any angle you want of your choosing, using the protractor, of course, to make it nice and perfect and wonderful. Once you have that done, hand it to me. You're welcome, by the way, to work with a partner. Hey, partner, if you'd like, you can do that.